Okay, quite an important concept in linear relationships is actually working from 2 points, not necessarily on a graph, even though this is what's up on the screen. Working from 2 points backwards to get an equation of a line. Okay, so in this example we haven't put 2 on the screen. I'll explain that in a little bit. But on the right hand side you can see a line with 2 points defined. And the question might be, what is the equation of this line? Okay, so it's not immediately obvious what the gradient or the y-intercept are, although you could probably work it out. I'm going to show you one method that works for everything. On the left there, what I've got is a what's called a general example. So it's got, instead of numbers, it's got some x's and y's, which might be a little bit confusing to start, but we're going to generate a formula we can use to do anything. Okay, so what we need to do first is to find the gradient. Okay, so in this example on the right here, I'm going to start with this one. To find the gradient, we need to do rise over run. Okay, so now to find the rise over run, rise is how far up it goes. Okay, so if you look at the y coordinates of these two, you see that it goes up by 2. And the way you work that out is you say 5 minus 3. Okay, the difference is 2. You can see that. The gradient, so the rise will be 5 minus 2, which just happens to be 2. Okay, so we're going to do the run as well. The run is going to be the difference in the x direction. Okay, so we have the difference, you should be able to see, is 3 minus negative 3. Okay, so we can write that out as well. 3 minus negative 3. Obviously, when you take away a negative number, you get a positive. You get 3 plus 3 is 6. Okay, so the gradient of this example is 1 over 3. Okay, so it's quite a shallow gradient. Now I'm going to transfer this over to the other side where we've got general points. Okay, and the reason why I did this part here is because I'm going to transfer these coordinates onto this over here. So if you have a look, the first thing we did was we said 5, which transfers. Okay, sorry. Let's just go back to these points here. I've designated 1.1 and 1.2. Okay, therefore we have a set of coordinates for point 1, so we call it x little 1 and y little 1. We just say x1, y1, and point 2 is x2, y2. Okay, so it's what these are, the x and y coordinates of point 1 and the x and y coordinates of point 2. Now, how we calculate that gradient using these points. Okay, so if you have a look back here, we did 5 minus 3, which corresponds to y2 minus y1. Okay, that's that one. Take away that one. That gives us our run. Now we divide that by x2. Okay, so in here we had 3 minus negative 3, which translates to x2 minus x1. 2 minus x1. Okay, now that is called a general equation for our gradient, and that's quite an important formula. Okay, so you need to memorize this. Okay, this is important. All right, it's a very it's a foolproof way of working out the gradient. Now, I wanted to go back to this one here. Okay, so back to here, we've got our gradient. Now, you could probably actually look at that graph and you could say what the y-intercept is, but I'm gonna work it out. I'm gonna show you how to work it out because they're not all this easy. All right, now, in fact, most of them are not this easy. So now, obviously, we can write our equation. Now we've got y equals. All right, we know it's y equals something x plus or minus something. Okay, so we know our gradient is 1 over 3, so it's going to be 1 over 3 x plus something. Okay, so instead of writing something, we give it a pronumeral value. We say c usually. Okay, it's just a stand-in letter we're going to use to help us work it out. Okay, so we've got too many variables there. but what we do know is we happen to know 2 points on this line. Okay, so what we can do to help us out, I'll just get a different color pen. We're going to substitute in one of those points. Okay, so it doesn't matter which one, you should get the same answer either way. So we're going to substitute. I'm just going to put it down here so I've got a bit of working out. We don't need the graph anymore. So we're going to sub in either point. Okay, so up here, either 3, 5 or negative 3, 3 should give you the same answer. All right, I'm going to do 3 and 5 because they're both positive. All right, so usually they're both the more positive. It's probably generally easier. It doesn't really matter. You just have to know your algebra. Okay, so I'm going to substitute in 5. So these are my x and y coordinates. Okay, so my y coordinates 5. So I'm going to put in 5 equals 1/3. Now x is 3. So we times that by 3, and we have at the end plus c. Okay, so now we have an equation that has only one variable. So let's work that out. So 5 equals 1/3 times 3 is obviously 1 plus c. Okay, so now we've got an easier equation. We take away 1 from both sides and we're left with c equals 4. Okay, so now we have this is our y-intercept. Okay, it's the bit on the end of the equation that tells us where it goes through the y-axis. Okay, so that's our y-intercept. Alright, so putting this back together with our equation, we will get, I'll use a different color again, y equals 1/3 x plus 4. Okay, so that is the equation of that line. Alright, now if we look back up here, I might even actually lasso, and I will control C, and I'm going to see if I can scroll this back up here. Okay, so there's my equation. Whoops. Anyway, so let's just have a look at this. If you were to calculate rise over run, you'd get 2/6, 1/3. Now, let's have a look at this plus 4. You should be able to see that it goes from 3 to 5 in the, 3 to 5 in the y direction. So halfway between 3 to 5 is going to be 4. So our equation, or our working out, makes sense. Okay, this was quite an easy one. They do get a bit harder. So good luck with that. I think that's about all. See how we go with that.